Hi, it's Rob. Welcome to this Cumulus Cycles video on getting started with the Arduino microcontroller. Now, I realize I've included this video in my Raspberry Pi playlist, and there are a couple reasons for that. First, if you watched the prior video in the playlist, you'll recall that I assembled a smart car chassis kit, which I indicated that I'd be using to build an autonomous obstacle avoiding robot car using an Arduino. Second, at the end of the video, I also mentioned that I'd be using this Arduino-based robot car to communicate with a Raspberry Pi-based robot car I'll be building over AWS IoT. So ultimately, the Raspberry Pi and the Arduino videos in this playlist will come together with my AWS IoT playlist videos to show you how to implement a multi-device IoT solution on AWS. If you're interested in the IoT aspect of this, I'll include a video to that playlist in the description below. Now, with that out of the way, let's move on and talk a bit about the Arduino microcontroller. Arduino is an open source electronic device that can read inputs such as light on a sensor or a press of a button, and based on these inputs, produce outputs such as turning on an LED or activating a motor. Arduino boards are microcontrollers, not microprocessors, which are computers with their own operating system, like a Raspberry Pi. Arduinos simply execute code, which is written in the Arduino Integrated Development Environment, or IDE, then uploaded to the Arduino from the IDE and stored in the board's firmware. If you're interested in taking a deeper dive into the differences between the Arduino and Raspberry Pi, I'll post a link to an excellent article in the description below. Now, to get started using an Arduino, you'll need a few things. First, you'll need the Arduino microcontroller, and for this video, I'll be using the Uno model. Next, you'll need a USB cable to connect the Arduino to your computer. And finally, you'll need the Arduino IDE, which is what I'll download and install now. Here on the Arduino downloads page, which you can get to by going to the Arduino website and clicking software, I'll click the download for Mac OS Apple Silicon since I'm on an M1 Mac. Here you can choose to contribute and download or just download. When the download completes, double-click the DMG file and drag the Arduino IDE icon to the Applications folder. Now in the Applications folder, find the Arduino IDE icon and click to launch. Now, I'll go ahead and connect one end of the USB cable to the Arduino and the other end to my computer. Then, looking at the Arduino, you see it's powered on, indicated by the illuminated LEDs. Now, let's turn our attention back to the IDE. Here we see a basic programming file, and in Arduino, our programs are called sketches. This file has two functions, a setup function and a loop, both of which have void return types, meaning they don't return any values. The setup function contains code that you want to run once on setup, and the loop function contains code that you want to run continuously in a loop. So what we'll do now is click File, then Examples, then Basics, and then Blank. And this will open a demo sketch which will blink the LED by turning it on for 1 second and then off for 1 second repeatedly. If we scroll down and look at the code, we see in the setup function, they're calling the pin mode method, passing it the built-in LED on the Arduino board and setting its mode as output. Then in the loop, they're calling the digital write method, passing it the built-in LED and setting its voltage level to high to illuminate the LED. Then they have a 1 second delay before calling digital write again, setting the voltage to low and turning the LED off and delaying for another second. Now what we'll do is click the check mark to verify that the sketch is syntactically correct. And here we see an error message, no board selected, and it's prompting us to select the Arduino board from the Tools Board menu. So we can do that by going up to the Tools menu, clicking on Board, then the Arduino AVR boards, and selecting Uno. Then we also have to select the port, which we could do by again going to the Tools menu, selecting Port, and then finding the port that the Arduino Uno is on. However, I haven't selected either of those. The board is still blank and the port is still blank. And the reason I've done that is in this newer version of the IDE, there's a select board option which will allow us to select the Arduino Uno on the port that it's currently connected to. Now if we go ahead and verify, we see the sketch was compiled and we have no error message. So the next step is to upload the sketch to the board, and we could do that using the upload button. And we see the upload is complete. Now if we go back to the board, we see the LED cycling on and off in 1 second intervals. Okay, now that we have the Blink demo working, let's go ahead and change things up a bit. What I want to do up here is declare a variable. Its type will be an integer, and we'll give it the name of red and set its value equal to 13. And this will represent digital pin 13 on the Arduino, which if we look at this diagram of the Arduino pins, we'll see is the first pin underground on the digital rail. Then I'll copy the red variable and use it to replace the built-in LED parameter that we're sending to pin mode and the digital write. Finally, I'll change to 1000 to 500 so we see a faster blink in this demo. Now I'll go ahead and verify the sketch. That looks good. And now I'll upload it to the board. Now that the upload's complete, let's jump over the board and see what this looks like. And now, in addition to the built-in LED on the Arduino, we see the red LED on the breadboard cycling on and off as well. Now, before we move on to the next demo, let's take a look at the circuit. Here, you can see I've run a black wire from ground on the Arduino to the ground rail on the breadboard. Then I ran another black wire from the ground rail on the breadboard to the row with the negative lead from the red LED. In the row with the positive lead of the LED, I added a 220 ohm resistor with the other end of the resistor connected to digital pin 13 on the Arduino using the orange wire. Now that we understand how this circuit was wired, let's go ahead and add 2 more LEDs while we're here. I'll start by inserting a yellow LED into the breadboard. Then I'll add another 220 ohm resistor in the row with the LED's positive lead and connect the other end of the LED to digital pin 13 on the Arduino with a yellow wire. And finally, run the negative lead of the LED to the ground rail on the board. Then I'll add a green LED following the same circuit configuration with a green wire running to digital pin 8 on the Arduino. Now let's go back to the sketch and make some mods. I'll start out by adding variables for the yellow and green LEDs, setting the value of yellow to pin 12 on the Arduino and the green to pin 8. Then I'll set the pin modes for yellow and green to output, and then add digital writes and delays for the yellow and green LEDs. Now I'll click the upload button, which will validate the sketch and upload it to the board. And now, looking at the Arduino, we see our new sketch is running, toggling between the red, yellow, and green LEDs. Now, let's move on to a bit more involved project where we'll use an ultrasonic sensor to measure distance and turn on an LED. This is similar to the video I created using an ultrasonic sensor with a Raspberry Pi. I'll add a link to that video in the description below in the event you haven't watched it and are interested. To get started here, I'll remove the yellow and green LEDs, resistors, and wires, but leave the red. Then I'll run a red wire from the Arduino's 5-volt power pin to the positive rail on the breadboard. I'll then connect jumper wires to the ultrasonic sensor. I'll use red for VCC, or power, green for the trigger pin, yellow for echo, and black for ground. Then I'll connect the green wire to pin 7 on the Arduino and the yellow to pin 8. Then I'll run the black wire to the ground rail on the breadboard and the red wire to the positive rail on the breadboard. And that's it for the complete circuit. So let's jump into the IDE and take a look at the code. Here I've created 3 variables. They're all integers, and one is for the LED on pin 13, one is for the trigger pin on the ultrasonic sensor, which will be on pin 7, and echo on pin 8. Then I have variables for value and time, which we'll use for calculating the distance. In the setup function, I'm calling pin mode for the LED and trigger pins and setting them to output, and then setting the echo pin as input. In the loop, I have code to clear the trigger pin and then send a pulse from the ultrasonic sensor. Then we'll calculate the distance by setting the value of time to pulse in on the echo pin, setting it to high. Then calculate the value using the time. And if the value is less than or equal to 10 centimeters, we'll turn the LED on, else we'll turn the LED off. Now let's go ahead and upload this sketch to the Arduino. And then take a look at the code in action. Starting out with no objects within 10 centimeters of the ultrasonic sensor, we see the LED is off. However, if I place my hand in front of the sensor, we see the LED turn on, then off again when I remove my hand. So that concludes this video on getting started with the Arduino. If you found it useful, feel free to give it a like. And if you'd like to be notified when I add more content, please consider subscribing to the channel. Thanks for watching, and I hope to see you in another video soon.